This video is going to be discussing inequalities and what their graphs look like. Before we start anything, we do have to memorize what inequalities are and what they mean. And you can see here we've got 4 inequalities, and we've got to memorize what each one represents. We have less than, greater than, less than or equal to, and greater than or equal to. And it's very important to know which one is which, and that'll make our life a lot easier. In example 1, the question is whether each number is a solution to x is less than 7. And all we're going to have to do is just plug it in. So instead of writing an x, we're going to write 9 is less than or equal to 7. Is that a true statement? Is 9 less than or equal to 7? No, 9 is not less than 7, so that means that this is not a solution. B, we have -1, so we're going to write -1 is less than or equal to 7. And that is a true statement because -1 is less than 7. So we'll write yes for this one. It works. C, 14 over 2 simplifies to 7. And when I plug that in, we've got 7 is less than or equal to 7. And even though 7 is not less than 7, it is equal to 7. And since we do have a less than or equals to sign, then we are able to say that yes, this is a solution. So what this means is that we can plug in -1 and we can plug in 14 over 2 into this inequality and have it be a true statement. It does work. It is what we call a solution. It makes it true. So when we look at example 2, it's basically the same thing, only this time we have a little bit longer inequality to work with. So if we look at our first A example here, we're going to have 2 minus 5 times, and I'm going to replace my x with parentheses this time since I've got more stuff on this side. And then I'll plug in a 3 since that's the number that we're testing. And follow order of operations. 5 times 3 is 15. And 2 minus 15 is -13. Is this a true statement? Is -13 greater than 13? That is definitely a no. It's not a solution. It doesn't work. That's an untrue statement. For the B example, we have -4. So we'll do the same thing we did for our A example. Draw our parentheses, and then go back and plug in our -4 here. Let's multiply. -5 times -4 will be +20. And 2 plus 20 is 22. 22 is greater than 13, so -4 is a solution. It does work. Let's talk about what the graphs of inequalities look like. A couple more things to have to memorize here. If we have a less than sign, we're going to have an open dot on our graph, and we're going to be shading to the left. If we have greater than, it's going to be an open dot, but this time we'll be shading to the right side. If it's less than or equals to, our dot on the graph will be closed and filled in, but we're still shading to the left just like we did with less than. If it's greater than or equals to, it's closed as well, but we're shading to the right just like we will for greater than. Let's look at our first A example here for number 3. We've got C is greater than -2. We're going to be using a number line. If you'll remember, if we have a number line here, typically we have 0 in the middle. When we go out from there, the numbers on the right side of the number line are the large numbers, and the numbers on the left are where all of our small numbers are when we have the negatives. And when we do negative numbers, they move backwards from the positive numbers. So what looks like a larger number like 3, when it's negative, it's actually smaller than a -1. So we've got to keep that in mind as we're working this out because we're going to be thinking about large numbers and small numbers here. So for our first one, we have C is greater than -2. Instead of starting with 0, I'm going to start my graph with -2. And then I'll just move out from there. To the right of -2, The next largest number is -1, and then I'll have 0. And on the left side, we're going to have -3 and -4. Now, if I come back up here to our little chart, we've got greater than. That means it's an open dot. And an open dot means that we're going to start with this number, but it's not a solution. So this -2, if I had plugged this in here, -2, that is not a true statement. -2 is not greater than -2. So that means that -2 can't be a solution, but it's just our starting place. So we have -2 here. It's greater than, and according to this, greater than means we shade to the right. So I'm going to make an arrow here, make it real dark, and we're going to make it go to the right of my number line. And that arrow represents where all of the solutions can be. I can plug in -1 into our inequality and make it true. We can make C be 0. 0 is greater than -2. All these numbers over here, we've got 50, we've got 100, we have 523. All of those big numbers are on the right side. And if I took them and I plugged them in for C, they would all work as a solution. Our B example will be the same way, only this time. Add that in there. We've got a fraction. 4/5 is greater than m. Now, before I start anything, I'm going to switch the sides. It'll be easier to graph if we have our variable on the left side. And when I do that, do you see how the pointy part of our inequality here is pointing towards m? I need to make sure that it's still pointing towards m even after I flip it around. So now when I read this, it's m is less than or equal to 4/5. Now, some of you may be wondering how in the world we're going to graph that on our number line. It might be easier to think about 4/5 as a decimal. So if we divide 4 by the number 5, we get the number 0.8. And 0.8 is between the numbers 0 and 1. So let me start with those. And if I fill in the other side, I'll have -1 and -2 here. So 0.8 is between 0 and 1. And it's a little bit closer to the 1 than it is to 0. So this is where I'm going to start. It's about right here. And since we have greater than or equals to, if we come up here, that means we have less than or equals to, we have less than or equal to, that means it's going to be a closed dot. So right about where I think 0.8 is going to be, I'm going to put my closed dot down. And since it's less than, that means that we're shading on the left side. So we'll make our dark arrow here on the left side. And so all the solutions for this inequality is going to be less than 0.8. And since this is closed in, that also means that 0.8 is a solution. I could plug in a 0.8 right here for m and still have a true statement. Our last examples that we're looking at today, this time I'm giving you a graph and we're going to have to write the inequality from it. So let's see what we've got here. We have our dot on 2, so we know we're going to be using a 2. And as far as a variable goes, I can use any variable I want to. And let's use D. Okay, so we have our variable, we have our number that we're starting with. Now we've got to decide what our inequality is going to be. We have an open dot that is shaded to the left side. When it's shaded to the left, that's going to be either less than or equals to. So I will put the less than sign down there. And since this is an open dot, it means it's just plain old less than. So the answer for A can be D is less than 2. For our B example, we'll need a variable, so let's try doing P. And we're starting on -6, so my number is going to be -6. This time we have a closed dot that's shaded to the right. Anytime it's shaded to the right, it's going to be greater than or equals to. And since it's a closed-in dot, it's going to be greater than or equals to. So I'm going to add in a little something extra to my inequality, the equals to sign. If you have any questions, make sure that you're asking in class. We'll see you then.